All right, let's differentiate a function which requires the use of a quotient rule. Let's remind ourselves of what the quotient rule allows us to do. If we have a function f of x divided by another function g of x, and I want to differentiate this function with respect to x, so if both my numerator and my denominator depend on x, then I can use this quotient rule. And the quotient rule tells me that I can differentiate one at a time, but there's a pattern that I have to pay respect to. So the pattern is low d high minus high d low over low low. All right, let's apply the pattern here. So I don't want to say f of x is equal to. I want to differentiate f of x. So what is the derivative of 2x minus 3 over 2 plus 3e to the 5x? So according to my pattern, and maybe we'll do another problem after this. So according to my pattern, it is low my denominator just copied down. So low and then d high, right, the derivative of the numerator, minus high d low I'm running out of colors here. D low and then all over. Oop, I haven't been paying attention. This is this was red, the derivative of the numerator. This was green, the copied down numerator. And I'm never going to find that purple again. This was the derivative of the denominator. All right, so low d high minus high d low all over low low. So 2 plus 3 e to the 5x squared. Right? That's your derivative. Let's do another one. Let's differentiate with respect to y to the 2 plus square root y over natural log y. Actually, let's make it a little bit more complicated. Natural log of 2y. Okay, so before I'm ready to differentiate, let's rewrite it as something we can use power rules on. So y squared is fine. Let's rewrite that as y to the 1/2. All right, now we're ready to differentiate. So what is the derivative of this function? It is, by my quotient rule, low d high minus high d low. Right, I had a chain rule in there. The derivative of natural log of something is 1 over something, and then times the derivative of that something. So low d high minus high d low over low low.